Hello guys, welcome back to Garuda classes. For today's topic, we are going to discuss about air density. Okay, so let's get started. So how can you define density? From the childhood, from school sections, we have studied about density. Density is defined as the mass of air contained in a unit volume. So fairly simple definition that if you take a unit volume, the number or the mass that it will contain will be defined as the air density. Okay, so the air density can be defined as, or you can say the density is defined as the mass of air contains in unit volume. Okay. Now, what will be this unit? Since mass unit can be gram or kilogram, so its unit is gram contained in the unit volume, and the unit for volume is meter cube. Okay. So its unit will become gram per meter cube or kilogram per meter cube. Okay. So these are the standard definition and units of that. Now we'll move forward. What are the factors that affect your density? Okay, what are the factors that might bring your density lower or higher? The first parameter we are going to discuss about is pressure. Factors affecting density. Okay. First parameter is density is directly proportional to your pressure. Okay. So for example, if you take a cube and compress it, okay, what will happen? Its volume, if you increase the pressure, the volume will shrink. And we know that if the volume is shrunk, the density will increase. Okay. So density is also been represented by the symbol rho. Okay. So as you increase the pressure, okay, the size of a volume, say example, this is a cube, okay, a unit volume. Now, if you start pressurizing this thing, what will happen? The shape will shrunk it down like this. Okay, due to the excessive pressure. Now, if your pressure is being increasing, what will happen? The mass is constant thing. Mass do not change, right? Mass will be the same. For example, it has 100 molecules, the 100 mass molecules. It also has 100 mass molecules. But what has changed? Its volume. If its volume has been changed, what will happen is the density? Density has increased. In simplest term, you can say that if this volume has this much space, while increasing the pressure, what will happen? The space between the molecules starts slowly reducing. Okay, so hence increasing the density. Okay, so we studied so far that increasing the pressure will also increase the density. Okay, the next parameter that affects it is your temperature, and it is inversely proportional with your temperature. How that will work? For example, take a say a piston which have a movable plunger. Okay. Something mechanism look like this. Okay, now this mechanism, what will happen when you start to give this a heat? Okay, say example, you start to heat this chamber. Okay, now this molecule, what will happen? The temperature is increasing. As temperature is increasing, what will happen? The molecules start to expand. Okay, they start to expand. Since this is movable, the plunger will go upward. Okay, creating what? Increasing the volume. Okay, the volume has been increased. Okay, the remaining, the other body, the lower body is fixed. Obviously, the plungers move upward, which creating more volume. More volume means your lower density. Okay, So as temperature increases, your volume is also increasing, so is your density is decreasing, okay, due to you are increasing the temperature. The next parameter that affects your density is humidity, and it is inversely proportional. So density can also be written as rho or symbol, and it is inversely proportional to humidity. Now this is a complex mechanism and beyond the scope for aviation purposes. But in order to just you have to know this, that the density of a dry air, okay, what is a dry air? That it doesn't have moisture present, okay, will be always greater than the density of a moisture. And if you want to remember, how can you remember this thing? Okay, you can do one thing. Okay, take this as dry air. Okay, now imagine this has same molecule but some presence of your water molecules like this. Now you can see the spacing has increased. Now spacing has increased. Okay. If the spacing has increased, you can see the density has been reduced. Okay. And there is a small shortcut trick. You can remember that hot, humid, high will reduce aircraft performance. Hot, humid, high will reduce aircraft performance. Okay. First, I'll explain you about how your density is being linked with your aircraft performance. So, in order to aircraft perform very well, we require winds. Okay. Why we require wind? Because it will give you lift. So, whenever there is higher density is present, your lift is increased. Okay. So, we technically require more amount of density. Okay. More density is required. So, what happens whenever there is hot weather is there? Hot weather, we have studied that as the temperature increase, the density is reduced. So is the performance. Okay. Again, humid, we have also studied that it is inversely proportional. Since it is inversely proportional, as you increasing your humidity near your coastline, whatever side you have, that is also reducing your aircraft performance. And high, as we know, as we go higher and higher in atmosphere, what is reducing? Your pressure is reducing. Okay. As you go higher, your pressure is reducing. Since these three parameters will reduce your density, so is your aircraft performance is also reducing. Okay. Now one question might arise in your brain that temperature is inversely proportional, right? But as we going higher and higher, the temperature is also reducing, right? But the pressure is decreasing. So why is that? I'm telling you, the pressure, the density is reducing as you go higher. Isn't that inversely proportional? I'm contradicting with my previous points. So see, definitely as you go higher, pressure is reducing and your density is also, let's first write about temperature. Temperature is also reducing, but the parameter that changes highly is your pressure. So the resultant of decreasing pressure and decreasing temperature, the higher amount of changes will be result due to the change of pressure. So in this context, your pressure play major role as compared to your temperature. Okay. The simplest term, as your pressure is the key parameter in reducing your density. Okay. We have seen as you go higher, the number of molecules start to reduce. So is your temperature because of by the mean of lapse rate. Okay. So you can say height inversely proportional to density. Okay. Go higher and your density will reduce. Cool. Okay. Now we'll understand the next topic or the next concept known as density altitude. Okay. So far we have seen pressure altitude. So what is meaning of density altitude? So assume, now forget all the parameters, all the things you have studied so far. Listen carefully. Now take example. Okay, look now. Say example, take two atmosphere. One is regular and one is a warmer region. So what will happen? Say what happened, you remember that ISA density at MSL is 1225.5 gram per meter cube. Okay? 1225 gram per meter cube. And as you go 2000, it became 1000 gram, and so on, it start decreasing. Okay? So we will rename this density. Okay? We'll rename as 0 feet. Okay? And 1000 as 10,000 feet. Okay? We'll rename what? 1000 gram per meter cube as 10,000 feet. Simplest term, this is called as density altitude. Okay. So wherever you find 1000 gram per meter cube, we'll call it density altitude as 10,000 feet. Okay. If you find it at MSL, you'll say pressure altitude is 0 feet. Okay. And your density altitude is 10,000 feet. Why it is 10,000? Because we are finding the pressure, okay, of 10,000 feet. Okay, sorry, we're finding a density of 10,000 feet. That is 1000 gram. Okay. For example, if you find the 1000 gram over here, okay, on this region, so we'll rename that as 10,000 feet density altitude. Okay. So this is the concept of density altitude. So you can say that density altitude is defined as the altitude above MSL at which given atmospheric density occurs in a ISA, International Standard Atmosphere, defined as the altitude above MSL at which given atmospheric density occur in ISA. Okay. So this is how it is defined. Now, what is pressure altitude? There are few things there are few ways in which you can calculate density altitude. First is by putting a formula. So basically, how can you define that? So you have a formula that dA equals to pressure altitude D equal to pressure altitude plus ISA deviation. In the first topic, we have discussed how to calculate ISA deviation into multiply by 120 feet. Okay. To be more precise, it is 118.8 feet. For simplicity of the calculation, you can calculate by 120 feet. Okay. The resultant will be roughly same. Or by putting this values, you can calculate your density altitude. Otherwise, you can also use your navigation computer in which you can calculate that easily. Now there will be a condition in which your pressure altitude will be equal to your density altitude. At which pressure? Whenever your current atmosphere will be equal to your ISA condition, that time your pressure altitude will be equal to your density altitude. The condition that your pressure altitude equals to your density altitude when your current atmosphere will be equal to your ISA condition. Okay, this is how you get your pressure altitude and density altitude to be equal. Okay. And the same thing can be defined by so if 1 degree Celsius temperature deviation from ISA equal to 120 feet. 1 degree Celsius temperature deviation from ISA equal to 120. The same thing. Now talking about the variation. Okay. Variation in surface density. And in the previous chapter of temperature, we have seen that your temperature is being changed according to throughout the day, it is changing rapidly. And we have discussed the temperature is directly linked with your density. So your density should also change. Variation in surface density. Okay. Density is inversely proportional to your absolute temperature. The temperature change throughout the day. Okay. So density is also changing. And lowest density will occur at the time when there is the lowest temperature, right? The density lowest, it is inversely proportional. So lowest density will occur when the temperature is highest, that is in afternoon, and the highest density will occur at the lowest temperature, that is after the sunrise. Okay, so your density is inversely proportional to absolute temperature. Temperature changes throughout the day. Okay, so density also changes. Lowest density occur at afternoons. And your highest density occurs just after sunrise. Okay. Okay, so we have discussed so far that as you increase the height, your density is also reduced. So it is roughly around 3% per 1,000 feet. And as you reach you reach around 6 kilometers of height, you will achieve almost half of the surface density. For example, by reaching about 6 kilometers, if the surface density was 1,000, you will be at around 500 feet, 500 gram per meter cube. That much density you will be at. And so on. By reaching 11 kilometer, you are 1/4, and by reaching 17 kilometer, you will be by 1/8. Okay, so reach half of the surface density. By reaching around 6 kilometers of the height, and by 1/4 of the surface density you can achieve by climbing to 11 kilometers of height, and 1/8 by reaching 17 kilometers of height. Now, apart from this, there are some latitudinal variation is also present. Definitely. Why? Because of the presence of your insolation property. Okay, if you have seen the temperature lecture, what happened? Your Earth is not perfectly inclined with the sun. It's not upright 90 degrees. We have some certain inclination of say 23.5 degrees. Just a second. Now take this Earth. Okay. Now the Earth itself is inclined. If you take this is the uh, polar radial. Now the inclination is around 23.5 degrees. So what happens? There is a property called as insolation. Insolation basically means that the amount of heat that is coming will be divided upon the area. Now, if this is the center line of the sun, okay, take this as the sun, large source of energy is your sun. Now, if the sun now the wave is coming at the center of the part. Now, since it is directly hitting this thing, the area is very small. Okay, so the amount of heat is being captured around will be higher. But as you go to near the pole, what happens? The surface area is splitted. Okay, your surface area is very much higher. Okay. You can see there is this entire beam spreaded across a larger area. Since it means spreaded across a larger area, your temperature is also, your heat is also not reaching that much high. Okay, and we have studied so far that your temperature density is very much dependent on your temperature as well. So due to this, there will be some latitudinal variation. Okay. So at pole, it will be a larger area. Hence, temperature will be lower. And at equators or at the tropics, tropics are basically called as the region between your Tropic of Cancer and Tropic of Capricorn, also called as the region behind, nearby your equator. Okay, and it's a much small area. Here's the tropics. Okay, so far we have studied that the temperature is lowest at the pole. So what will happen with the density? Definitely highest density will be at the pole and the lowest density will be at the equatorial region. So you'll find the highest density at poles and the temperature will be less. The lowest density will be at equatorial region. Also called as tropics. This is applicable up to height of 8 kilometers. Why it is only applicable up to height of 8 kilometers? Because as you're going climbing higher and higher, one more effect is taking place. That is change of or fall of pressure, right? So after the 8 kilometers, the reverse thing happens, that your density becomes less at poles and more at the equators. So after 8 kilometers, your density become more at equator than the poles. Okay, that's all for this topic. It's relatively quite small topic, and we'll discuss the next topic in the next section.